Hello audience, today I will deal with structures which are found in the sedimentary rocks. There are two types, primary structures and the secondary structure, and I will deal with both the type in separate videos. Starting with the primary sedimentary structure, I'll give you the outline what I am going to deal in this particular video. I'll give you a definition of sedimentary structure. I'll say how are they identified and described, their use in geological reconstructions, the types of sedimentary structures, their use in understanding the sedimentary history of the basin, and then I will give you a summary. Now to start with, the disposition of a group of mineral grains in a particular fashion generates observable design on the sedimentary beds that gets preserved in the rock record. These structures, which are formed on the sediments, are observed and studied either on the top of the bed or on the lower part of the bed or even inside the bed, which we call inner surfaces of the sedimentary rock. These sedimentary rocks, these sedimentary structures, they help us to understand the process and the environment in the depositional basin. They also tell us about the direction of the depositional currents in the ancient rocks. These are both syn or post-depositional events, so they are all recorded in the sedimentary structures. We can also decide about which is the top of the bed or which is the bottom of the bed by studying these sedimentary features. And we also can find out the rate at which the sediment has been supplied to basin, whether it was a slow sedimentation or it was a very fast sedimentation. The uses are, the structures are features that show a variety of interesting and significant geometries that are produced by physical, chemical, and biological processes operating on sediments during and after the deposition. They are either organic or inorganic in origin. The first significant layer which is formed here is they are called stratification. Stratification is the first bed, and depending upon the thicknesses, they are given different terms. Like more than 100 centimeter called very thick bed, 30 to 100 centimeter thickly bedded, 10 to 30 moderately bedded, then similarly 3 to 10 thinly bedded, 1 to 3 centimeter very thinly bedded, 0.3 to 1 is thickly laminated, and less than 0.3 are called very thinly laminated. Now there is a feature, there is a photograph, field photograph, which actually explains which are the laminations, which are the bedding with the horizontals and inclined bed. You can see that is marked there. Those are inclined beds. These are the bedding planes, and these are the horizontal beds. So, as I told you just now, right in the beginning, that there are two types of sedimentary structure, primary and secondary structures. The terms like bedding plane, laminae, layering, strata, and stratifications are invariably used in describing the sedimentary structures. The primary structures are formed mechanically by physical process, physical mechanisms. They are formed during the mechanical deposition of insoluble sediments. So I'm specifically talking about insoluble sediments because the soluble sediments will go into solution and get washed away. But only the insoluble sediments are transported, and they form either beds, then call it bedded, or they form sheets, then you call sheeted, and if they form layers only, they call layered. An individual layer is called bed. Now, how the beds are formed? First thing, just to tell you how the beds are formed. Sediment grain is there. There are three ways what sediment move onto the sediment surface. One is rolling, saltation, and suspension. In the first diagram, you can see that the grain moves to another position, then it rolls back, rolls up the other, and then again move. So there is a called rolling movement. The saltation is that the grain moves and jumps over a place, then what you call hopping type of thing, they hop over the other point and then moves away. And in suspension, they are in all direction, so the grains are moving irregularly without any special direction. So these, therefore, those which are formed in the grain movement, rolling and saltation, are called bedded, and those suspension are called suspended loads. Now, these layers are of different types. They give you either they are in the parallel or discontinuous, or they can be wavy parallel or called curved parallel. So, in all cases, similarly, non-parallel beds also have the same type: planar, wavy, and curved. Some of the bedding types are two types. One, the flazzer bedding. The flazzer bedding has got a that ripples override one over the other, and it forms sort of a what you call flazzer. A shape is not exactly lenticular, but one lenticle overrides the other. The other type is lenticular bedding, where the beddings are they are separated. They are not coming. The type of sedimentary rock beds are separated from each other, and they form in the form of a lenticule, or they are called wavy bedding, like this. The third one. The bedding type. This is the same one which I have just told you. The same one again. Here parallel, non-parallel, and discontinuous with the different sketches. An example, field sketch, field diagram, a rock which shows the parallel bedding. You can say the bedding is absolutely parallel, thinly, except some places where there is some curvature. Otherwise, it is all parallel bedding. These are sandstone shale intercalations. Another parallel bedded limestone and shale unit. You can see that they are all parallel bedded, and they sometimes extend for miles together, and they are extensive in the rock. And these are consolidated, hardened limestone shale intercalations. Another parallel low dipping shale, you can see at the bottom. The whole area is just parallel beds, and they are very low dipping, about 1 or 2 degree dips. And this is found in the Vindhyachal rock, in Vindhyans rock of India. Another one is a porcelainite rock. Porcelainite is a rock formed by volcanic ash. So when the ash slowly falls and it forms parallel layers, and these become hardened, and then we call it a porcelainite. This is again from the Vindhyan ranges, where they form parallel beds alternating with sandstones. This is just a photograph to show how these porcelainite beds are sampled, because it requires a very sophisticated method of drilling, and you can see that parallel bedded rocks are being sampled for chemical analysis. This is also another horizon from the Vindhyan group, where the shale and sandstone intercalations are there, extensive over a large area. This is particularly known as the Sirbu shale in Vindhyan terminology. The other type of bedding is a cross bedding. The earlier one was a parallel bedding and plain bedding. It is a cross bedding. Word itself says that the two set of beds are crossed with each other. They are inclined dipping beds, bounded and often wrapped up by sub-horizontal beds, making a set. They are a group of similar sets, co-sets. 3 sets of beds are called top set, bottom set, and fourth set. On the basis of feature, on the basis of the shape, the cross beddings are of 3 types: planar wedge cross bedding, planar tabular cross bedding, and lensoid trough cross bedding. This is all diagrammatically shown, the same one. The left side is the planar tabular cross bedding, on the right side the planar wedge shaped cross bedding, and the third one is the trough cross bedding. This is the same planar in another way, the 3-dimensional way it has been shown, where you can see the upper ones are all sets, and these co-sets produce they interact with the other sets and produce a fourth set and bottom set. So you get a trough cross beds, and in the upper part you get planar cross beds. So this is a diagrammatic representation of what I just now told you. They are also classified on the basis of angle of truncation. A simple truncation at 15 degrees, planar truncation is over 15 degrees, and trough is when less than 15 degrees but beds are curved. Now some features here: large scale trough cross bedding in the quartzitic sandstone rock, and you can see in the bottom there are two sets of bed, one horizontal and another one is angular. The series of set of cross beds are repeated over the whole section. Another example here which shows very clearly gently inclined four set beds and horizontal bottom set bedding in a coarse sandstone. Now you can see there are two different angles very clearly shown on this side. Another one is herringbone cross stratification. This is also one of the type in which there is angular beds terminates against the horizontal bed. But in this case, two angular beds come and join together, and they give a shape of a herringbone. Herring is a fish, herring fish, which is central part of the bone. They have got this type of arrangement, so therefore it is now called as the herringbone stratification. Another very good example of cross bedding with a thin layer of foreset bedding is from Jodhpur sandstone, reddish color, ferruginous sandstone, where you can see the cross beds. Another one is ripple lamination. These ripples form cross beds, so therefore the cross beds form ripples. So it is a mixture of ripple and cross bed, and it gives you rise to what we call as a climbing ripple lamination. Another type of structure is ripple marks. These are wavy structures characterized by a crest and a trough. These are dune-like features of sand or silt whose long dimension is at right angle to the direction of current. Now the photograph here shows a incomplete ripple with incomplete mud cracks. Many times, many scientists have actually misidentified these mud cracks. They thought they are some organic structure and called them trace fossils, but they are actually incomplete mud cracks. As I showed you, the ripples are formed by both current or by wave. So this is an example of a wave ripple where the both lee side and other side is is almost symmetrical. Another side is called palimpsest feature, sinuous or catenary ripples here. Interference ripple which you have got multiple direction of currents. The ripple morphology. Ripple has got particular shape. It depends upon how they are formed. When they move from one end to the other end, they produce the lee face, and when they move to the other side, it is called the stoss side. The maximum height to which this ripple reaches is called a summit point, or also known as crest. The ripple height, ripple wavelength, ripple index, all these things will be explained in the next slide. This is a diagrammatic representation here. You can see the water is moving from left to right. This is the direction of flow. And the water surface from left to right, it reaches first, slows down to the bottom portion, and that is called trough. And from trough it is again lifted up and go up to a particular height, and then again start falling. This maximum height to which the ripple reaches is called the summit point. And after the summit point, the grains started dropping again in a very fast manner, and that is called the brink point. And brink point finally reaches to the trough again, and then again it is repeated. And that is how we call a train of ripples are formed. So these nomenclatures are the top crest of the fall is called summit point, and the point where the sediment become unstable and started falling on the right side is called brink point. And some of the indices which are used for describing ripples are the ripple length is between the two trough points, and this is called trough point, and between the brink point and the summit point you have a crest, and that is how the ripples are formed, and they move from left to right. Shape of ripples are also two types, two-dimensional or three-dimensional. They are either straight crested or three-dimensional, sinuous, linguoid, catenary, or lunate. They are either asymmetrical or current ripples. Asymmetrical are the current ripples, or they are symmetrical, which are also wave ripples. Let us see a diagrammatic show of formation of symmetry. You can see that there is a water oscillation on two sides. So therefore, sometimes sediment goes to the right, sometimes sediment moves to the left. Therefore, the lee side and starch side both are of the same angle. So therefore, they are called symmetrical ripples. This also tells you the direction of the ripple. Now you can see the sloping side will give you the direction of the ripple. Symmetrical wave ripples I just showed you earlier. This is another example of a symmetrical wave ripple. Both sides, lee side and starch side, both are of the same angle. Asymmetrical, you can see the difference in there is a difference in angulature from the flow direction. The arrow shows on the right side is a low angle, and the other side, left side, is the steep angle. The ripple type is also same, once again explained by another diagram here. The symmetrical ripple, which are normally found in beach, or asymmetrical ripple found in the dunes. The dunes mean. Here again, this another diagram to show the difference between current ripple and wave ripples. This straight crested small ripple and symmetrical wave ripples. When there is a current is flowing in one direction, then you have a different type of crest. They are either straight crested, they are sinuous, or catenary, or they form lunate or linguoid, or wave form ripples. Now some field outcome examples are: this is a linguoid lunate ripple. This is a rhomboid small current ripples from the Yamuna sand plain. This is a linguoid current ripples again from the Yamuna sand plains. There is also adhesion ripple. This is a very unusual type of ripple which is formed when the water depth is only about few centimeter or few millimeter. So in that case, the air comes and air makes a ripple on the water, and the water gets slightly disturbed. Therefore, they form very small ripples, and they're called adhesion ripple. The adhesion means the sticking, ripple is sticking to the bottom. And there is an example of a field outcrop of a current ripple. Another structure which is very important in primary sedimentary structure is a graded bedding. When the sediments start depositing in a particular basin, and especially when an environment becomes little quiet, so what happens that the coarser grains or the heavier grains settle faster, and the finer grains remain in suspension, and they settle at the last. So they form grade, one a coarse grade to a normal. You call it normal grade. That means from a coarser grade that you see in the upper one, normal grade, the bigger one, the coarser grade at the bottom, and the finer one. So this is called fining upward cycle. Fining upward cycle is very common, especially in fluvial river deposits and other things. On the other side, there is a reverse grading, where the finer at the bottom and the coarse at the top. These are called coarsening upward cycle. This is very common in the coastal areas, in a high energy area, tidal flats, where there is the fine grains settle first and the coarser grain come last. The graded beds show progressive variation of grain size from coarse at the bottom to the fine upward. They are commonly formed in deep sea environment by turbidity currents. There is a graded bedding in a calcareous mudstone. Now you can see there is a series of beds, one after the other. A graded bedded, then followed by a parallel laminated sediment. Again graded bed, parallel laminated sediment. So this is a type of a graded bed which you see in the outcrops. Now in summarizing, we discussed the sedimentary structures and large scale features which show variety of interesting and significant geometries that get produced by the physical, chemical, and biological processes. Sedimentary structures can be classified into primary or secondary structures depending on the mechanism of formation. Primary structures are also known as mechanical structures. They are formed due to mechanical action of waves and also by currents. Primary sedimentary structures include bedding and stratification, cross bedding, gridded bedding, ripple marks, mud crack, raindrop ripples, soil structures, etc. Ripple marks may be symmetrical or asymmetrical. The shape of ripple is described as two-dimensional if the crests are straight, or three-dimensional if the crests are sinuous, catenary, lunate, or linguoid. Thank you.